Welcome to the fifth and last edition of the Rust Munich Meetup for 2023.
Welcome everybody here at Doc Financial. Great to see so many Rust fans so shortly for Christmas. Appreciate it. As you have guessed, well, we're using Rust here internally. What we're building is financial infrastructure for other companies, banks, and so on. So obviously, safety, security are paramount. So it's more important to be correct than to have nice uptime and so on. So therefore, Rust is obviously a perfect choice for us, and we'd be happy to discuss with you afterwards then also with in the lunchroom with some more snacks. We have drinks, we have also everything cold, so please just raise your hand when something should be gone. Everything is there, and I wish you a lot of fun tonight. Please use the last opportunity of the year for networking. It's the most important thing here. And our first talk will be Bastian. Bastian is a developer here at the company. It will be a short talk, basically just I'll let him introduce himself, right? So thanks again and have fun.
Hi, I'm Bastian. I'm backend developer here at Doc Financial for like 3.5 years now, starting with our old C++ system, and for 2 years now developing everything from scratch in Rust. And today I want to talk a little bit about our Open API, what we're doing, how we're doing it, and showing some stuff that might be new to some people, because we are not only using Rust, there are some small things. So yeah, I'm going to talk about our requirements, about existing solution that we did not choose, and our solution, and then I will demonstrate a tiny pet store API for you. Okay, the requirements for our API might be different than other APIs. We want to have layers. Layers in our case means we're having a public API and an internal API. While the APIs are the same for like 95%, there are some tiny differences. And we didn't want to write everything twice. So that is one of our main requirements. We want to be able to do some layering on the Open API side. We want to reduce the developer errors. Writing API spec and documentation is hard. Everybody knows that. Nobody wants to do it. And there are tools that do help with API generation from the code, but usually it's very easy to make errors, forget something. You don't update the status code of the response, and the documentation is wrong. Respecting the developer time, yeah, writing documentation takes a lot of time, and when you write code and need to have the documentation in sync, it will take time to ensure they are in sync. Having a look every time, is that still what I wrote in the documentation? It takes a lot of time, and that's what we wanted to reduce. Remove hidden parameters. It's kind of, we have one existing solution that adds a lot of hidden parameters. We want that the API documentation is actually just the bare minimum of what it needs to be and describing what the actual server is doing. Okay, existing solutions. There are Open API generators that can generate Rust code. That was introduced Java into our build stack, and most important, we need to maintain templates. Maintaining the templates is not that easy. You change something and, well, next time it's not compiling, and you need to look in the templates, which you cannot compile on their own. So it's hard to find the errors in the OpenAPI generators, usually. The next solution would be Poem, which is a HTTP server. Great. I mixed some slides, but so Poem is a complete server, and they offer API generation from the actual code that you have, which is nice. But actually, we already started with our HTTP API before we started to write the OpenAPI, and we were already using XM. And migration was something that we did not want to do. Yes.
It might help to explain what OpenAPI is to those people that don't. I know what it is, but maybe not everyone knows what OpenAPI is, because all of this doesn't make any sense if you don't know what OpenAPI is.
Okay, I was thinking that most people know OpenAPI. So OpenAPI is a spec, the UJSON or YML file. This describes routes, models of a REST API. You can generate clients and server stubs from the documentation and have front ends. I will show some in the end. Yeah. Poem did not match our requirements because they cannot support layering. The last solution that there exists is UToiper. That was our initial approach because it was easy to integrate with our XM server. And basically, you write your routes and handlers, and you can use Rust attributes to tag stuff to the handlers. And UToiper would use those tags to generate the OpenAPI spec for you. But it can go out of sync very easily. You can forget to update even full response bodies, and then the documentation is really, really wrong. We had that multiple times. So it's really easy to go out of sync. That was a huge problem. And therefore, we had to write our own solution. So our own solution basically starts with JSONnet. That might be strange because we want to write OpenAPI and Rust, but we have this layering. And this layering is, as I said, the API is identical for like 95%. We only want to change tiny details. Like in the response body, we want to add, for the internal API, we want to add a trace ID. So you can write 2 OpenAPI specs, like files that are like 20,000 lines long, and just change 1 line. That's not very nice to maintain. And JSONnet is configuration language. You write JSON, plus you have functions in JSON, and you can generate JSON out of it. So what we are doing is we are writing our OpenAPI spec, the public one in JSONnet. Then we write our internal API by taking the public API, just taking some models and extend the models, add fields to it, and add new routes that are only accessible via the internal API. That's why we just have one thing to maintain. And from that JSONnet, we actually generate a library crate. The library crate has the schema, all the models, the structs, enums, and everything, plus some conversions from JSON into those models. The code also generates a trait that has all the routes. So we have a stub that we have. We implement one client that needs to implement this trait. And the code that implements that is basically 10 lines. So, and we even can use the same code for public and internal, just the conversion of the data types is a little bit different. And this whole thing is currently based on XM. We're planning, where we thought about making it open source at some time, so then we would maybe need to move the straight dependency on XM, but that's what was useful for us at the moment. Yeah, and that said, I'm going to show you how this is working actually. For that case, I'm opening my IDE, and I might start with the public API. This is our JSONnet. basically I'm importing the routes for the partner, for the public API. And then I say I want to have a new API. This is the public pets API, taking it as pet store API. The routes itself, so JSON config language, you can import stuff. The routes, the example is pretty easy. I'm just defining one JSON object. This local dis is just helpful. You could use self everywhere, but it's kind of common in JSON that you create a local variable that is this. And then we are importing the models, we are importing the filters, and then we are defining routes. So I have the version 0 pets API here with a post that will be the method to create a pet. It receives the create pet model. I can add some nice documentation here. I can add headers. In this case, I'm adding an idempotency header that is kind of defined by us internally. And then I'm saying, oh, the response of this is a tool 1. I created an entity. I created a pet. I can also just, as an example, have a description here, and I can just easily import Markdown. It's just importing a string basically and putting the description in place. And as OpenAPI supports Markdown, it's just there, and it will be Markdown as you wrote it. I can define a listing operation on that. And for that listing, I'm defined a filter. The filter going to the query parameter. So I'm saying queries. I'm adding a filter and the pagination data. And it will return me a 200 with an array of pets in this case. And a continuation token. Continuation token is special to pagination. I don't know if you know that, but you don't have to in this case. And I can also define a pets getting, where I define the pet ID as part of the path and define a segment in the JSON net here. And the segment, just saying it's a UID, and it will be parsed. So what, having a look at the models first. So the models, I can create a pet with a kind that is an enumeration of pet kind, dog and cat, for example. It could be even a tagged enum with more data contained. But for simplicity, we're staying with enum here. And I have the pet. So after I create it, I'm getting a pet back with kind the name that I set in the create endpoint. What's going to be generated? This is my library, and I have, let's have a look at the pets model. The pets model, you see the file is generated. It's deriving from domain type. Domain type is our internal wrapper for converting JSON into the model that we defined and generated. It does the error handling for us. So if I have the UID and I specify something that is not a UID, the conversion, the parsing of the JSON will directly fail because it's not a UID. And it will give out the same error for that. It generates a pet. It generates the pet kind enum with some renames because we wanted to have it in capital letters. Can be different for other people. This should have been generated in a different file. This is trace information that should have been in the admin API, but maybe I messed something up with the example. So it generates the models and it generates code for the routes. Let's have a look at the creation of a pet. So the creation of the pet, we define the request, and the request has had the create pet model. This is the body here, but it also defines an idempotency key that we set as header. This is all contained in the request, and it has claims. In our case now, it's an access token claims. So because you need to be logged in to create a pet. So it's collecting all the data that we require for the request into this request struct, and has an enumeration for the response. In this case, I just defined the created response. So the recreated string comes from the official tool 1 is created If I would have defined a 200, the enum variant would be okay. And it creates a router for me. It defines a constant for the pass, and then it just has a method router with a context. The context is something that we define when you actually implement the API. You need to define the context. Yeah, it has some generics, like you need to have a verifier for the access token claims, and then it calls this create pet function. And what this create pet function is basically doing, it's reading out the exam stuff for us. So you see it's reading the JSON body in this line. Yeah, great. It gets an auth result and the JSON body. It extracts all the data for us, the claims from the auth, from the token, and it then creates this request saying that this was generated, and it calls our create pet function, which is the trade. And then it does some error handling in case the response was created. We're checking that actually, if our API implementation would return a 200 here, it would fail because we defined the API to be 201. So in case something went wrong with our API documentation, we will know it because it will fail directly if somebody tries to use the API. There are some other matches that also some error codes that we defined happen. If not, if it's some other error code, it will also give us an error message in our tracing. Okay, then let's have a look at how I actually implement that. I'm creating a struct public pets API, nothing more. This is basically what in the end is this context. I can add whatever I like here. What database connection? There's some leftover user service client that might be used for user management and checking the access token claims. But I can put everything there, and I need to define an internal function that is used to create us an XM router. That's all. Then I'm implementing a trade. I actually do not implement it. I stopped at to do. And this is what we have in a library trade. From that library, now I go to the public API trade, which is a binary. And I'm just saying, I want this JSON.NET file here. And I use our API build to generate OpenAPI from it. That will actually generate an OpenAPI file for me, even if this small document it's already 1,000 lines long. I will show it to you in the browser later. And then I just have a main function where I read some arguments from the command line, bind the address, create my public pets API. I'm getting back the pets API. I'm using the inter-router function to get the pets router. And then I define some, so this block is basically showing elements UI. If you don't know it, it's an UI for OpenAPI. This there for demo purposes. And the main code is, I'm saying pets router, I'm merging it into the OpenAPI router, and I could have more tags like OpenAPI tags, different API domains separately. I can merge them together into one server. And then I'm just spawning a server. This is our internal server framework, but you can use whatever you like, and attach the router to it. Spawn with router here. And that's basically all to have the public API running. I'm going back to the library now to show you how we extend this API. For that reason, in the admin API, I want to know trace information. So internally, every request has a request ID, and I want to retrieve the IP address, for example, for a specific request ID. So this is a new model that I'm adding only for the internal API, for the admin API. And I'm also again in the admin stuff. I'm importing first the public stuff. I'm defining mix and function. It's just convenience that can be used to extend stuff. Then I have a partner corporation, and here you see I want to define all the models that are in the public API. I want to prefix the name with admin underscore. It gives us a second, well, for the generation of the models, it gives us a module name. We can prefix it, and we can clearly differ between public and internal models. This together, I'm just putting into another JSON object. So this full block here is the JSON object where I define, where I put a mix-in on the public pet model, and I'm adding a request ID, which is a UID, and I'm just adding it to the existing pet model. I'm importing now my admin model, and I create a new endpoint, which is version 0 admin trace, and I'm putting the request ID that I want to retrieve, and I'm returning my new admin model with the trace information. And it will generate me the same code basically. And I write a second binary that does the same thing as the public, just implementing the struct for the internal API. And now I'm going to run this. Oh, it's already running. So this is our public pet store API. It has the pets tag, and I have a create pet method here. It's version 0 post. This is the documentation in Markdown. It defines the headers that we defined, and it has the body. I'm creating a kind and a name, and it will return me the ID of the pet, name, kind. I can list pets, and it will show me that the body of the response is an array of ID, kind, and name, the pet. I can have the get pet, which returns 1. And if I now stop the public API and start the admin API, right, you already see there's this get trace information method with the request ID and the IP address. And even if I now go to create pet, for example, you see, no, not the create pet. Oh, it should have been there. Where is it? Oh, it's all in the list. Okay, something now went wrong. It should have been having a request ID now, but it's not there. That's a pity. As always, if you want to demonstrate something. So in theory, in our production system, it works. We need to check why it's not working. It used to work when I tried it first. Yeah, and that's basically what I wanted to demonstrate today. This leaves me for the final slide, question and answer time.
Question for me was not clear. Your generation also stubs for server side, or
we only server side in our case.
So basically, you use the JSON.NET configuration to generate stubs for server side.
We use JSON. No, we're going via the API, Open API. From the JSON.NET, we're generating the Open API, and from the Open API, we generate the code.
I see. So this is the normal generator for server.
No, this is our custom one.
Oh, okay, your custom. Okay.
We wrote the. So maybe we can show the library. Actually, it also has a build.rs file. So we're putting the JSON-nets in, creating the API. So we have generate API and we have generate Open API spec. Basically, 2 functions. One will generate the library code, the models and the routes and the trait, and we have another function that will generate the Open API spec, and then we implement basically the trait that we have generated.
Just a follow-up. Do you feel the need to do contract testing nevertheless? Or you're confident that with this method you can trust the compiler?
I mean, we're testing it. We're not testing if the documentation matches, but there's still options left where we can mess up the documentation and like miss the contracts, but usually we're at least confident that the bodies and the models and the status codes are correct. That's the main thing. If some documentation string is not matching, that's not that important because we have technical writer that will write that together in a better way anyways.
Thanks.
Yep.
So, as you said, this is this bespoke custom system. When building it, did you consider using the Rust source code in some way or form as the source of truth instead of a third place where you then generate the places from?
I mean, yes, we were using Axum and the UTOIPA to try to generate the open API from the Rust code. And yeah, we had promised that the bodies changed, or because you have to define a body for Axum, and then you have to define the body the same in a different attribute for UTOIPA to generate it correctly. And it was, you could just change the body of Axum and UTOIPA would not notice that there's a mismatch in the contract, and then the API was wrong.
I see what you mean, right? Like, so there are tools that already try this approach, as you probably right. But like, that's only one way to do it. Theoretically, if you have a proc macro or some other kind of view inside of the Rust code, you could pull out all the information you need and annotate things like documentation that you can't infer automatically. So just because this tooling doesn't exist, but like, why didn't you want to build that tooling?
We wanted to start from Open API. We wanted to basically have API first, and we actually thought of writing Open API directly. But then we thought it's hard to maintain this huge JSON, and then doing it twice for internal and public API. That's why we came up with the JSONnet, which gives us the possibility to reduce the duplication there and still go to Open API and write an Open API generator.
Okay.
Yes.
Do you have a way to do error handling? For example, if you use get pet, and you don't find this pet, so you return a 404.
Yeah, that's basically then up to you. Let me show some code of the public API, for example.
Because you define 400, right? So
you
another line in JSON.
So that would be no, not here in the handler. The handler, for example, here. This create pet returns an API result, and the API result is basically either the successful response or any of the error status codes that you have.
Okay.
Yep.
Is the Open API generator that you wrote, is that public?
We think about making it public. It's not yet. It's very tightly coupled with the system. There are things that we need to consider changing, and we're not 100% API compliant, so we're not able to generate all the code just because we don't have the time. We implement the parts that we actually need. For example, today I started implementing min and max lengths on arrays. We didn't require it, so the code was not generated, but it's pretty easy to extend on other stuff, but we're doing it step by step. And once we are on a level where we say, now it's in a state where we can publish it, we consider doing it.
What did you use to display the Open API spec in the browser?
Elements. It's was Spotlight. Is it? It's where is it? It's powered by Stoplight. Open API design Stoplight. You can find it if you search for Stoplight and elements.
Okay, thanks.
How good is the generated code? How often do you have to modify or manually edit?
We're not modifying it at all.
Okay.
So the code is good. We trusted it, and it's not that we need to change it, the generator very often. The only thing changing the generator is like having new features that, like generating the min max length today was, I needed to tell the generator that it should not generate a vector for the Open API array type, but something else that we defined and that will check the ranges.
Speaking of types, what was that custom string type you had?
Custom string
I don't remember which file it was.
in Rust or in
In Rust.
Rust custom string. I don't know.
Like limited string or something.
Yeah, that one. That, for example, this thing, we define external types that has capabilities. The limit string, for example, can define minimum and maximum. In this case, for a name, I decided that the minimum length should be 6. If it's would not be any limited string, it would generate a normal string. But in this case, as we defined some boundaries on it, a range, it generates another type that will fail when you try to convert it from JSON into this type. It will fail directly when converting from JSON.
But in general, it's a regular string.
Yeah, we're trying to use the regular types as possible, but for having limitations on strings or arrays, we need to define some types. Okay, 3 seconds of silence. No.
Another question. This is more API design. Can you expand on the need of using layering in the API spec, or in general?
It's like basically like the example. I want to enrich the existing data for our internal purposes. We want to show more data that the end user should not see, and yeah, we could write a second API for it, but as I said, it's 90%, 95% is identical. That's why it didn't make sense to write another API. We try to use the same code for everything. Internally, our API layer is just converting types. Both internal and public use the same internal services. It's just we take the external description is different. We have a different conversion into the internal types, and that's all.
Thank you. But you have to implement the server twice?
Yes, we have
The handlers.
the handlers. Yeah, we have to implement them twice, but they are both going into this one function in the end, because we only need to change the conversion into internal types. So we have the handler implemented basically for the internal types, and we just from the generate the code where we implement it twice, we just call it and say into, and we have to implement the conversion. That's all.
So where you stopped at to do in your production code is just internal method dot into.
Yeah. Okay, this time 3 seconds of silence.
Cool. Perfect. Thank you. Thank you.
my side. Thank you for having me here. I want to tell you today just a short story about pitfalls in feature unification. Very shortly about me, my name is Simon Gasse. I originally studied electrical engineering and computer science, made a tour into deep learning for automotive and healthcare, but I started with Rust in 2020. And that was when there was COVID and a lot of time for everything else. And now since 1 year, I'm a full-time Rust developer for embedded systems at ESA Labs, which by now is part of Accenture Industry X. So the story that I want to tell you about is something that some of you might have experienced in your developer life as well. I added a new feature, it passed a review, it also passed CI, then I merged a patch, and I went home happily. And when I came in the next morning, what I saw was that the nightly build failed. And I looked into the nightly build and it was my patch. So I thought like, okay, maybe there was just some hiccup in CI, but it turned out that it was actually a failure. And I was just very surprised. How come our CI did not catch this? And then I started investigating. And this investigation led me to something that is in hindsight pretty obvious, but that can hit you if you don't expect this to happen. I tried to reproduce it in a minimal example, and this is what I want to walk you through. So we'll look at a workspace setup. I'm not exactly sure back there in the row you will be able to read it. Is it possible, Bastian? Okay, but I'll also go explaining a little with it. So we have a very reduced to the minimal workspace with two binary crates, app A and app B, and a utility library. In the utility, let's look in the binary crates. They both depend on the utility library. One of them also depends on Tokyo. And one important difference, maybe hard to spot
So then, welcome back. I'm not exactly sure what was the last time that was visible in the stream, so I will go back one slide to the reproduction example. Again, we have a workspace with 2 binary crates, 1 utility crate, and we depend on different features of this utility crate. In the library, we have the nested modules to get properties, one in a sync fashion, one in an async fashion. And yeah, now we look at how we use it. And we just use the library once in the sync fashion, once in the async fashion to get properties and print them. This is reduced to what we need to show the problem. Now, this was the state of the workspace kind of before I added my new feature. And the crates that I was using were completely unrelated to each other. And I added a feature that needed a nested submodule to be used in one of them. And so I changed this one app that I had, and I depended on something for which I needed the async submodule of the utilities library. This worked without problems. The IDE was happy. There was no squiggles or anything that something is wrong. Also, when I built and checked, everything worked. So I was quite happy with it. I even wrote a test for it, and the test was also successful. And so if I would run a cargo build, everything went through it. CI at that point just did a regular cargo build, was happy with it and approved the patch, went through review, and then it got merged. Now, the question was, why did we see the next morning the nightly pipeline build failure? And the thing is that the nightly pipeline built the crates in a different way. Essentially, it was doing this. So it was running a cargo build for the specific package. I see some nodding heads, so I guess some of you have run into this. If you look at the error, it just said it could not find this submodule in my bigger module. So the submodule Tokyo in my properties module. But then again, I got it through CI, I got it through build. So it was interesting to see what is now the difference of building the complete workspace and building just this crate, and why did it not occur earlier? And the answer to this is feature unification, as the talk title gives away. So we'll do a really short recap on that. If we have a workspace with, let's say, those 2 crates, and they depend on a common dependency, let's say one depends with this properties feature and the other with properties and Tokyo. What cargo will do, it will say, I will build this dependency only once. This saves compile time, that saves disk space. And both of them will use the same version of this dependent if we build the complete workspace. And this is something to be aware of, and some rules follow from that we also see in the cargo reference. One is that features should be additive. So if you have several features, they should complete the picture of what your crate can do. They should ideally not be mutually exclusive. A common anti-pattern, especially if you're in the embedded space, is that there's a lot of crates that have a no STD feature. Ideally, you would instead have a STD feature with which you opt in to having the standard library instead of opting out of having something. Another thing is if you really have to have mutually exclusive features because there's, I don't know, some backend that you want to use versus another backend that you use, then it would be a good idea to add a compile error that is guarded on those features being active together. Because then if you do that accidentally or it happens through feature unification, you will notice right away at the compile stage. Now, talking about some things that could go wrong. The case that I ran in is one of the most benevolent ones. Just the separate packages build broke. It's not too bad. We catch this problem early, doesn't go to production or anything. There's even a nice tool that you can use to check if your individual build would work, which is called Cargo Hack. We'll go through your whole workspace and try to build all of the contents individually. Next thing that is a little annoying is if you have feature unification and you didn't think it would happen, it will inflate your binary size. For many use cases, that is not very bad. That's not a problem. But there's use cases like deploying something as WebAssembly or in embedded space having to flash something on very limited memory, where inflating the binary size for nothing is a big problem. Then going up the ladder of bad consequences, you could have features that harm the performance. So imagine you have some library that uses internally an algorithm to solve something, and there's a more exact version that is super slow of it. And somewhere at the other end of the workspace, you're using the slow version for something, and in another place, you want to use the fast version. If features are additive, you may not notice that this gets into your program and that you're using the way slower version. After I ran into this problem of the broken build, I actually reviewed this for one of my other crates that I'm maintaining, that this is not the case, that I'm not pulling something in that will harm my performance. And then the worst consequence I could think about, that luckily for us never happened so far, and I hope it will not happen, is that you actually have someone at the very other end of the workspace in some development, debug, testing crate opt into a feature that will disable some security in a dependency that you use commonly. And that then, I don't know, you deploy something that has TLS switched off. I think most crates do not easily expose this. So even if you switch something like that off, you will have to use a method that says something unsafe or danger, and then whatever you do without security features. But still, it's something to keep in mind that could go wrong. General recommendation is that for things where it matters, so maybe things that are publicly exposed in production or things that are deployed publicly, you should maybe consider always building it separately. Still, there's of course a trade-off. In your CI, you may still accept to build the whole workspace as a first go, because you will build a lot of patch revisions during the development, but then later maybe as a gate job, or especially before you deploy something, you may want to build it separately. Now, when we talk about feature unification, there's one other thing to mention that is interesting in terms of workspaces, and that is the resolver version. Maybe some of you have had the situation that you built something in a workspace and you got a warning using resolver 1, although default is 2 for 2021, please change it in your cargo tomo. What this whole thing is about, I think it was Rust version 1.51 that introduced a new version of the dependency resolver. With the 2021 edition of Rust, this became default, so that all crates would always use this resolver. However, if you have a workspace, then even if all your crates are 2021, the workspace, or I think at least if you have one that is 2018, but maybe even if you have all 2021, the workspace will fall back to the behavior of And we're back. Okay, so there's not that much more to say about this. So this were the 3 changes with the resolver. The takeaways maybe from this talk is maybe you read about feature unification at some point when you got into cargo and then forgot about it for a while, but it may come back to bite you if you don't watch out for it. If you have something in production, you may want to consider to build it separately, either as part of a CI job to see if there's any difference popping up, or always before you deploy it. And yeah, and one other thing that I did not put on the slides, I have, okay, so here are the links later for the reference. There's a nice description of the feature unification in the cargo reference, and also about the dependency resolution. One thing that you can do is running a cargo tree to see how dependencies come in, but the output is quite long and you have to read it very carefully to really know which of those will be unified. So I would reread the chapter in the reference when I the next time have to work with the cargo tree output. Yep, and that is the story that I wanted to tell you. I hope it was interesting for some of you, and thanks for the time. Yeah, Bastian?
Does cargo hack show fixes?
You mean things that you would need to do to fix the broken build?
Yeah.
As far as I know, not. As far as I know, it will just stop. You can instruct it to continue even after the first failure, so that you would see all the crates that would fail in your workspace. But as far as I know, it's not like with Clippy where you can say, please auto add this missing feature to something else. Yeah, but it's still quite a useful tool, especially to see, okay, there's nothing wrong happening there for the broken builds. It does not protect you from opting into weird features that will make your library behave worse than you intended to. Yeah.
Do you think this should maybe be a Clippy or actually a compiler error? Because it seems like the only reason that it worked if you build the whole workspace is because of, I guess, compiler laziness, right? Optimization.
Yeah.
But in a correct build, it shouldn't work.
Yeah, so in my opinion, I could imagine it should be a lint on some level. However, I don't think it should be a Clippy lint. Clippy in this case, or not being too deep in Clippy itself, but only using it as a user, is always focused on the crate level. And this is kind of in between crates. I absolutely agree that it is fallout of optimization. Not sure how many of you have worked with Bazel, but there are lints, for example, in Bazel where you say, okay, I have this C++ dependency, but and you're using the following thing from a namespace that is only by accident coming in from another header to your file, and you have not declared your explicit dependency in your Bazel file. I've seen that in my C++ time. It would be something like this, I would say. So where we would say, hey, look, you are using a feature that only exists because you did not sanitizedly include it somewhere. But so I would agree, it would be nice to see that. For now, I think the only way to notice it is would be to compare what is the tree output maybe for a certain crate from you building in a workspace versus building only this separately. I'm not sure whether it's quite wasteful to resolve, but in the end, you should be able to just do the resolver runs, not compile the actual code to notice that something is missing. But yeah, maybe at some point it is worth a lint coming in. Yeah. Yeah.
Do you know how it works if you have stuff like no STD, but you have different targets, for example, an embedded target and a general Linux target? Wouldn't that mean that it tries to build STD anyway for the embedded target, or target in a sense?
Yeah, I do think that can happen without having it tried out too much. So what I do remember is that if you have a workspace where you have, for example, an embedded project that has no STD, and you say in the config of that project that you only want to build for this specific ARM target, for example, and then you have a server. We had that in a hackathon where we had like a server project as a backend, and then we had a small chip where we actually compiled for an embedded device. And then we could no longer build on workspace level because it was not possible at that point to tell Cargo, hey, this crate, you have to build no STD for this target, but this you can build for the other target. We did not get it to work at that point, but that was, I don't know, half a year ago.
I guess Resolver 2 would solve that.
Hopefully, yes. Yeah. Okay, yeah.
So you said earlier that if you really care about the output, build it as a separate package, right?
That is, in my opinion, the way that you get what you define in your cargo toml for the crate, yeah.
I agree. I think it's sound nice. But like, imagine you have a separate build system outside of cargo, and it somehow tries to pull build artifacts out of the cargo build, like parsing cargo tree and whatnot. Will those binaries end up in a different place, or do you have to give it a different profile so you can separate the outputs? Because imagine you build everything because you want to run tests, right? You just say you build a top level thing which builds everything, and you specifically want this like nicer output of the same thing, right? Is it differentiated on the file system level, or do you have to differentiate on the profile level?
It's a good question. I must admit that I'm not that deep in build systems to give a good answer here. I do think that for having worked a bit with Bazel, that you can define your rule on how you will generate an artifact. And if you dare write a rule, this step of unifying features is probably something you would need to build in. So if you just call Rust C under the hood, you have to specify which features you use. And so you would either say, hi, I want to have all my dependencies built with the features only that they declare. And so there will be two different artifacts. Or I actually do this magic that Cargo does as well. So I think it is something you would bake into the build system. And then also in Bazel, you would find it in a sandbox. Yeah.
Maybe a little bit off topic, but what's the state of the art currently to find unused features? I know there have been some approaches working around, but I'm not sure if something is being used.
That is also
the opposite of what you do.
Also a very good question. I haven't looked into it, and I also still want to look more into options of, for example, cargo hack. So maybe there's a command line option, or there may be an option that allows you to declinate through feature combinations, or that would be a place to put it in there. But unfortunately, so far, I'm not yet aware how to spot features that are unused. I do think it could be useful, although the resolving to what you really use is not that easy. If you take, as an example, Tokyo, and in one of let's say presentation demo crates, people just say Tokyo features full, and it opts into plenty of features. Then declinating out which combination of those that also activate other features would make a sufficient set for your code base. I'm not sure you can do that without iterating through the options of which opt-in there are, or at least resolving to the leaves of your dependency tree and then saying, okay, I need those leaves. How could I get them? Which different combinations of higher level opt-in features could get them? Good question, good idea on how, maybe to spot things that you could optimize out for code size or other things. Okay.
Cool. Thank you.
Then, thank you very much for your time.